Good evening, everyone. So, today we are going to discuss about amplifiers continuation. Today's topic is transformer coupled amplifier. Okay. So, before going to discuss about today's class transformer coupled amplifier, first I would like to revise previous class topics. Okay. While coming to the previous class topics, our first topic is amplifier. Okay. So what is meant by amplifier? It is a device which is used to increase the strength of weak signal is called amplifier. Okay. And while coming to the next topic, classification. Or before going to that, here one important word is there, amplification. What is meant by amplification? Okay. The property of amplifier to increase the strength of signal is called amplification. Amplifier means it is a device which is used to increase the strength of weak signal. So amplification means it is the property of amplifier which is used to increase the strength of weak signal. So while telling about amplification, it is a factor or it is a property. But while coming to the amplifier, it is a device which is used to increase the strength of weak signal. Okay. And while coming to the next one, in our last class we are also discussed about classification of amplifiers. Okay. So here while coming to the classification, first the amplifiers are classified based on the coupling. Okay. How many types of amplifiers are there based on the coupling and what is meant by coupling? Okay. Coupling means what? Connection between two stages is called coupling. So connecting the output of one stage to the next stage is called coupling. So here to connect the output of first amplifier to the input of next amplifier, here we are using two elements, resistive capacitive network and transformer. If we are using resistor and capacitor to connect the output of one stage to the next stage, then the amplifier is called RC coupled amplifier. RC coupled. For the sake of coupling, here we are using resistor and capacitor, then that is called RC coupled amplifier. And next one is transformer. If we are using transformer to connect the output of one stage to the next stage, then that is called transformer coupled amplifier. Next one is called what? Direct coupled amplifier. If the output of one stage is connected to the input of next stage without using any coupling element, okay, without using any coupling element, if we are connecting the output of one stage to the input of next stage, then that is called what? Direct coupled amplifier. So like that, based on coupling, the amplifiers are classified into three types: RC coupled amplifier, transformer coupled amplifier, as well as direct coupled amplifier. And while coming to the next one, according to the signal is to be amplified, amplifiers are classified into two types. One is called small signal amplifier, other is called large signal amplifier. According to the signal is to be amplified, amplifiers are classified into two types: small signal amplifier as well as large signal amplifier. And while coming to the next one, according to the parameter and according to the signal is to be amplified, the amplifiers are classified into current amplifiers are there, and also voltage amplifiers as well as power amplifiers also there. So three amplifiers are there: current, voltage, power amplifiers. Okay. And while coming to the next one, according to the number of stages are used to produce the output. Okay, according to the number of stages are used in the construction to produce the outputs. Again, the amplifiers are classified into two types. First one is called single stage amplifiers. Next one is called multi-stage amplifier. So see here, in single stage only one transistor is used. It acts like an amplifier. In addition to the transistor, stabilization network is there. But in multi-stage amplifier, two or three amplifiers connected together. If the circuit having more than one amplifier to produce the efficient outputs, then that is called multi-stage amplifier. Okay, and while coming to the last classification, so that is according to the frequency range. According to the frequency range. So according to the frequency, the amplifiers are classified into two types: audio frequency amplifiers as well as radio frequency. So while coming to the audio frequency amplifiers are used to amplify the signals having the frequency in between 20 Hz to 20 kHz. So why? Because the audible range is there, means if any signal is there in between the audible range having the frequency of 20 to 20 kHz. Okay, 20 to 20 kHz. If the amplifiers are used to amplify the signals in between the 20 to 20 kHz, then those amplifiers are called audio frequency amplifiers. And while coming to the next thing, those are radio frequency amplifiers. So radio frequency amplifiers are the amplifiers are used to amplify the signal strength above 20 kHz frequency signals. So these are called what? Radio frequency amplifiers. Okay, so this is the classification belongs to the amplifiers. And while coming to the next topic, what is the gain of multi-stage amplifier? Already I said you what is meant by multi-stage amplifier. What is said by multi-stage amplifier? If two or more stages are connected together, then that is called what? Multi-stage amplifier. Here one important question is there in our last class. What is the need of multi-stage amplifier? What is the need? So single stage amplifier is unable to produce the sufficient outputs, that is not sufficient to drive the load. Okay, so the output produced by the single stage amplifier is not enough to drive the load, so that multi-stage amplifier is essential. If two or more stages are connected together to produce the outputs, then that is called what? Multi-stage amplifier. Okay, if two or more amplifiers are connected together, the output is produced, then that is called what? Multi-stage amplifier. And here coming to the term multi-stage in multi-stage, two or more amplifiers are connected together. So in multi-stage, if common emitter transistors are connected together, then that is called cascade amplifier. Okay, only common emitter is connected to common emitter, then that is called cascade. In multi-stage amplifier, if it is the combination of common emitter as well as common base configuration transistors, then that is called cascode. Okay, cascade is there, cascode is there. In most of the cases we works with cascade only, but cascode is also there in some cases. Okay, so cascade means common emitter amplifiers are connected together, then that is called cascade. Cascode means if common emitter is connected to common base, then that is called cascode. So finally, what is meant by multiplier, whether it may be cascade or cascode? The multi-stage amplifier means internally it consisting of more than two amplifiers, and here the output of first stage is connected to the input of next stage, and so on until we are reaching the last stage. Okay, so and while coming to the important parameters belongs to the multi-stage amplifier is, one is gain, other one is frequency response, last one is bandwidth. So while coming to the gain of individual stage is generally defined as the ratio of output to the input. So okay, gain of individual stage is defined as the ratio of output to the input. But while coming to the multi-stage amplifier gain, it is defined as the product of the individual gains. Okay, the overall gain is equal to what? Product of individual gains. And see here, while coming to the next one, frequency response. So it is a graph that may be drawn between the frequency and amplitude of the given signal, okay, or given output. What is meant by frequency response? It is the graph that indicate the relation between the frequency and amplitude of the given signal. And next one is called bandwidth. So what is meant by bandwidth? bandwidth, the term band indicate what's group, band of range. So maximum is there, minimum is there. So bandwidth means the group of frequencies, those are in a range of 70.7% of maximum gain. Okay, the frequencies, okay, for example, these are the frequency curve. So where it will attain 70.77% of gain. Okay, the range of frequencies, okay, and these frequencies will attain the 70.7% of maximum value of its gain. Range of frequencies which attains the 70.7% of maximum value of its gain is called what? Bandwidth. Okay. How many number of parameters are there belongs to the multi-stage amplifier? 3 parameters are there. What is first one? Gain, frequency response, bandwidth. Okay. And while coming to our next important topic in our last class is RC coupled amplifier. So already I told you in our last class we have discussed about two-stage RC coupled amplifier. Simply the diagram is like this. I draw like this. Here one capacitor is there, C input, and here V input voltage is there, and here CE, CRE are there. Like this the diagram is like this. So here how many number of transistors are there here? 2 transistors are there and 3 coupling capacitors are there. C in is there, CC is there, C out is there. Okay, and both circuits having the stabilization network R1, R2, and also emitter bypass capacitor CE and resistor RE. So each and every single stage having stabilization network R1 and R2, okay, and RECE bypassing capacitor resistor is also there. So while coming to the construction of two-stage amplifier, it consisting of 2 transistors, okay, and output of one transistor is connected to the input of next transistor through the coupling capacitor, okay, and here it consisting of 3 capacitors, okay, C in is there, CC is there, C out is there. And here C in indicates input capacitor. So here the input voltage is connected to the base of the transistor T1 through the coupling capacitor. Input voltage V in is connected to the base of the transistor through the coupling capacitor. Okay, and here the C in input resistor acts like a blocking capacitor. So what is the need of this capacitor? It will isolate the circuit from the input voltage and it will allow the DC, and it will allow only the AC voltage and it will block the DC voltage. So that it is also called blocked capacitor. It will allow the AC voltage and it will block the DC voltage. Okay. And same function is done with help of coupling capacitor CC and output capacitor Cout. But here CC is used to connect the output of first stage to the input of next stage. Means it will placed in between the output of first stage, that is across the collector, and input of second stage, that is across the base terminal of the T2. So it is connected to the collector of T1 and base of T2. In this way it will connect the output of first stage to the input of next stage. Okay, and while coming to the stabilization networks R1 and R2, these are used to increase the strength of, means these are used for providing the biasing and stabilization. So what is meant by biasing? It provides the emitter base junction is in forward bias condition and a collector base junction is in reverse bias condition. And in this way, if emitter base is forward bias condition, collector base is reverse bias condition, finally the transistor work in active region. And coming to the transistor T2 also, same way the resistance R1, R2. And it acts also like a stabilization network. So stabilization means the output is constant irrespective of variations. Irrespective of variations in the input. And here the capacitor, emitter, bypass capacitor and the resistor are connected in parallel. And those are indicated with RE and CE. And it will provide the low reactance path to the amplified signal. And this is the construction. And while coming to the working or operation, When supply voltage VCC is switched on, the transistor will increase the strength of given signal and the output is appeared across the collector terminal. And the transistor always provide 180 degrees phase shift from the input terminal. And this signal must be given to the transistor T2. Okay, and again it will provide the phase inversion. So total 360 degrees phase shift will be occurred. Okay, so in this way the signal strength will be increased. So this is about our last class topics. So now we are going to discuss about two-stage transformer coupled amplifier. It is very similar that of RC coupled amplifier. So in construction, the RC coupled amplifier and transformer coupled amplifiers both are very same, except the coupling element resistor and capacitor is replaced by the transformer. Cause of here it is replaced with the transformer. Okay, here it is used to increase the strength of high frequency signals. Okay, so in the construction of two-stage transformer coupled amplifier, like two-stage RC, it consisting of two transistors like this. It consisting of two transistors. Okay, but the output of first stage is connected to the input of next stage through the transformer. Primary winding is connected to collector, secondary winding connected to the base of the second transistor. Again it having stabilization and biasing network. Okay, R1 and R2, and both are having same, and emitter bypass resistor and capacitors also there, and input signal is there. Okay, so the diagram is similar that of RC coupled amplifier, but only the main difference is here transformer is used as a coupling element. Okay, once check the diagram. So this is the diagram of transformer coupled amplifier. So once see it carefully, it is very similar to that of RC coupled. Two transistors are there, T1 as well as T2, and resistor, biasing and stabilization network R1 and R2 is there for both stages. Emitter bypass capacitor CE, emitter bypass resistor RE are connected in parallel. At the same time, second stage also having same. Input signal is there, supply voltage is there. But only the difference is what here transformer is used in between the two stages. Transformer is used as a coupling element, and the primary winding is connected to the collector of the transistor 1. Why? Because here the output is appeared across the collector terminal of T1. Output is appeared across the collector terminal of T1, and this output, okay, output is appeared across the collector terminal of T1 connected to the primary winding. Okay, and connected to the primary winding, and the secondary winding is connected to the base of the T2. Only this is the difference between the RC coupled and transformer. Wherever here also transformer is used. Why? Because it may be connected to the next stage or it may be connected to the load. Okay, so this is the construction of transformer coupled amplifier. So how many number of transistors are there here? Two transistors are there here indicated with T1 and T2. Each and every stage having resistor, biasing and stabilization network. What is the need of biasing and stabilization network? It is used for providing emitter base is in forward bias condition and collector base is in reverse bias condition, and also provide the stabilization. That means output is constant irrespective of the variations in the input voltage. Here more one important factor is there that belongs to resistor R1 and R2. So biasing means not only making the emitter base is in forward, collector base is in reverse bias condition, it also make the operating point is independent of temperature variations. If it depends on the temperature variations, leakage currents will be increased so that self-destruction of the transistor is occurred. So self-destruction means what? Thermal runaway. So to protect the transistor from thermal runaway, here stabilization and biasing network is made with potential divider biasing network R1 and R2. And these emitter bypass capacitor and emitter bypass resistor are used to provide the low reactance path, to the transistor. And see here, the input signal, while coming to the operation, the input signal is applied to the transistor T1 through the capacitor C. Okay, and here the capacitor is used to connect the input signal or given signal to the base of the transistor T1, and it will not only connect the inputs, it allow only the AC signal and it will block DC signal, so that it is also called blocking capacitor. Okay, and when the input signal is applied, the transistor will increase the strength of the signal and produce the output across the collector terminal of the transistor. When the output is produced across the collector, the primary winding will transfer it to the secondary winding according to the Faraday's laws of electromagnetic induction. What is meant by Faraday's laws of electromagnetic induction? When the conductor is placed in magnetic field, okay, it will cut the magnetic flux and EMF will be produced. When a conductor is placed in the magnetic field, it will cut the magnetic flux and EMF will be induced. So according to the Faraday's laws of electromagnetic induction, the voltage that appeared across the primary winding is transferred to the secondary winding of the transformer, and this secondary winding is connected to the base of the transistor T2, and whatever the voltage transferred from the collector of T1 to base of T2, it is again amplified and the strength is again increased and it is produced across the output transformer. Okay, from this we may be connected to the load or it may be directly connected to the other load. Okay, so this is about what construction and operation of transformer coupled amplifier. Okay, whatever I explained, that is there in the slide. Once see the main reason of for low voltage and power gain of RC amplifier. So here one drawback is there for RC coupled. Already this is there in disadvantages: low voltage and low power gain. Transformer couples are used. Already I said you, transformer coupling is used to increase the frequency of the signal. Okay, means to increase the strength of high frequency signals. Here we are using transformer. Once see the circuit details, T1 is the coupling transformer, where T2 is the output transformer. The collector resistor RC1 is replaced by the primary winding. Secondary winding is replaced between the voltage and, okay. So everything is there, I already explained. Once you see the slides, simply. Here R1, R2 provide the biasing and stabilization. Okay, and C provide the capacity. Already explained, R1, R2 provide the biasing and stabilization network, and emitter bypass provide the low reactance path to the amplified signal. Okay, already I explained everything. So working when AC signal is applied through the capacitor to the base of first stage transistor, the amplified signal through the primary of coupling capacitor T1. The induced voltage across the secondary winding of transformer is fed to the input of second stage. How the voltage is induced, already I told you, according to the Faraday's laws of electromagnetic induction, the voltage must be induced from primary winding to secondary winding. Okay, so this is about what construction and operation of transformer coupled amplifier. And see here, while coming to the advantages, so first advantage, there is no loss of signal power in collector to base resistor. So what is the main advantage? There is no loss of signal power. Why there is no loss of signal power means, in RC coupled amplifier across resistor, some amount of voltage must be dropped. Why? Because V is equal to I into R. V is equal to I into R means what? When some amount of current is passed through the resistor, automatically voltage drop must be occurred according to the Ohm's law. V is equal to I into R. When some amount of current is passed through the resistor, voltage drop must be occurred. That means V is equal to I into R. So cause of that reason, in RC coupled amplifier some amount of signal will be lost, but here in this there is no loss of signal power in collector to base resistor, and it provides a higher voltage gain. Okay, it provides a higher voltage gain, and it provides an excellent impedance matching between the input and output. And what it will provide? Excellent impedance matching between the input and output. Okay, these are the different advantages of a transformer coupled amplifier. So every device having some advantages, at the same time having also disadvantage. So see here the frequency response is very poor. So while coming to the frequency response of RC coupled amplifier, the frequency response must be constant over some time, like this. Over some frequency ranges, the frequency response is constant. But here in the transformer, frequency response is very poor. And this transformer produce hum in the output. Some noise is there in the output. And it is costly, bulky, particularly at audio frequencies because of its heavy iron core. Okay, if we are working with transformer, must and should it is a bulky device. And also it is costly because of the transformers are expensive compared to the transistors, capacitors, resistors. Okay, so what are the demerits of this transformer coupled amplifier? Frequency response is poor. Transformer produces hum in the output, means noise, and it is costly and bulky, particularly at audio frequencies. It is costly and bulky, particularly at audio frequencies, because of its heavy iron core. Because of its heavy iron core. Okay, these are the different advantages and disadvantages of what? Transformer coupled amplifier. And while coming to the next one, frequency response of transformer coupled amplifier. First of all, what is meant by frequency? The curve that must be drawn between the frequency and gain or the amplitude of the given signal, then the curve is called frequency response. What is meant by frequency response? The curve that must be drawn between the given voltage, either it may be the gain or something, and the frequency of that particular signal is called frequency response. The transformer coupled amplifier, the output voltage is equal to the product of collector current and the reactance of primary winding. Okay, here one small difference is there compared to the RC and transformer coupled. Okay, here the transformer coupled amplifier, the output voltage is equal to the product of the collector current IC and the reactance of primary winding. Okay, in that way the reactance of primary winding is how much? Okay, F is equal to 2 pi XL, and here the frequency response of the transformer coupled amplifier, means the diagram is shown below. See here, this is the frequency response curve of transformer coupled amplifier. So see here, already I said that the curve that must be drawn between the frequency and gain of the given voltage is called frequency response. Okay, and see here the frequency response is always poor, means not at all it is constant at any time. Initially it is increased and somewhat constant, again it is increased and decreased. So like this, the curve is not constant at all the time, so the frequency response becomes very poor compared to the RC coupled. In RC coupled the curve is like this, initially it is increased, but after increment it is constant over the range of frequencies, afterwards it is decreased. But for certain range of frequencies between F1 and F2 it is constant, means what? Here the frequency response is very good, constant. Here it is not constant, so that it is called poor frequency response. Okay, and see here At high frequencies, the capacitance between the turns of winding acts as bypass capacitor, so which reduce the output voltage and hence gain. So what we explained in the slide, see, at high frequencies, at low frequencies, at high frequencies, why the voltage gain is reduced? The capacitance between the turns of winding acts as a bypass capacitor. Okay, at high voltages it is reduced and at low voltages it is reduced. Why it is reduced at high frequencies? So why it is reduced at high frequencies means the capacitance between the turns of winding acts as bypass capacitor, so that it will reduce the output voltage and hence gain. And see here in the above figure, it is clear that the gain is constant only over a small range of frequencies as compared to the RC coupled amplifier. And it follows therefore that there will be a disappropriate amplification of frequencies in complete signals such as music signal or speech signal, etc. Okay. And see here, hence the transformer coupled introduce frequency distortion. So what happened here? Cause of capacitance between the turns of windings acts like a bypass capacitor which reduce the output voltage. Output voltage is reduced and hence gain is also reduced. Cause of this, the distortion must be increased. Due to this capacitance between the windings, one main disadvantage is there. What is that? The frequency distortion must be increased. Noise must be increased. And see here, while coming to the next one, two-stage direct coupled amplifier circuits. What is our next topic? Two-stage direct coupled amplifier circuit. The name itself indicates two stages are there, and it is a direct coupled. Already I told you what is meant by direct coupled. No coupling elements are used to connect the output of one stage to the next stage. What is the theme of direct coupled? No coupling elements are used to connect the output of one stage to the input of next stage. So see here the output of this stage T1 is connected to the input of T2 without using any capacitor or transformer. So that it is called what? Direct coupled amplifier. Okay, so that it is called what? Direct coupled amplifier. Here see, the same transistor T1 is there, T2 is there, T3 is there, but while connecting the output, if we apply the input at base of the transistor T1, the signal must be amplified and it will provide the output across the collector. So through the collector, it is connected to the base of the T2 without using any coupling element. And next the output is appeared across the emitter, and this output is connected to the base of the transistor T3, and finally we getting the output across the collector. But either T1 to T2 or T2 to T3, no coupling element is used. No resistor or capacitor or no transformer is used. The output of T1 is directly connected to the input of T2, and the output of T2 is directly connected to the input of T3. So in this way, no coupling elements are used to connect the output of one stage to the input of next stage. Okay, no coupling elements are used. That's why it is called direct coupled amplifier. Okay, and see here, this RC means capacitor, resistor across the collector resistor simply. Collector resistor either across T1 or across T2 or across T3 are used for providing collector biasing. So in biasing, fixed bias, collector bias, emitter bias are there. So here this RC is used for providing proper biasing. Okay, and while coming to the working, when the input voltage is applied across the base of the transistor T1, the output must be increased and is appeared across collector, and the output from the collector is connected to the base of T2, and the amplified version is available across emitter, and then the output across the emitter is given to the base of T3, and finally the amplified version we are getting at the collector of T3. So in this way the signal strength is increased and produce the output. But because of no coupling elements, there will be a chance of adding disturbance signals ripples, so that more noise is produced. More noise is produced. And see here, once see the slide, whatever I explained that is only there in here. It is used for only low frequency applications. And here in these cases coupling devices, capacitor and transformers cannot be used. Already I told this, because of electrical charges of these components becomes very large at extremely very low frequencies. So why we are avoiding this and why we are designing direct coupling means, if we are using capacitor and transformer or resistor, the wiring elements, all these are wiring elements, so that circuit becomes complex at low frequencies also. So without using these components, capacitor and transformer, circuit becomes very easy and simple. At the same time, and these elements are using or not using also at low frequencies, not a miracle is done. So that's why avoiding it, the circuit becomes simple and providing same accuracy at low frequencies. Of course, for high frequency signals it is not useful, but at low frequency it is similar. Okay, and see, at low frequencies one stage is directly connected to the next stage without coupling element. Okay, at low frequencies, if we are getting the better amplification, we are moving with what? Direct coupled amplifier. So already I explained the first stage uses here NPN transistor and second stage PNP and so on. The collector of one stage is directly connected to the base of next stage. I already said this. And the collector of last stage is directly connected to the load. Okay, these are the construction or circuit details. And see here, while coming to the next one, working. So the weak signal, whatever the signal we are going to amplify is applied to the base of the first stage transistor Q1, and it is connected to the amplified signal appears across the resistor RC Q1. And this amplified signal drives the base of second stage transistor Q2 for further amplification and is available at RC. Already I explained everything. If once you understand the concept from the diagram, no need to read the theory. If you understand the concept or working from the diagram, then it becomes very easy to write also. If you buttifying or mugging the theory, there is no use. Whole we are getting from the diagram only. Construction, where it may be operation, once you know the diagram, if we are able to explain it with diagram, then we are getting original knowledge. Okay, and see here, this is the frequency response of DC amplifier. So already I said you what is meant by frequency response, the curve that must be drawn between the frequency of given signal and gain, frequency f, and also gain units are decibels. A gain is indicated with A, units are decibels. Frequency is indicated with F, and units are hertz. And here in for low frequencies, the output is constant. Okay, for low frequencies the gain is constant. After low frequencies, after certain frequencies, only the output going to decrease. That's why it is very suitable for low frequencies. For low frequencies, it will provide the constant gain, so that it is applicable for only low frequency signals. Okay, and see here, while coming to the frequency response, already explained. For low frequency it is constant, at high frequency the gain is reduced. And while coming to the advantages, already I said the circuit becomes very simple. Why? Because no transformers are there, no resistors, no capacitors, coupling capacitors are there, only transistors and single resistors are there. So that circuit becomes very simple and it uses minimum number of components only. What are the minimum components? They only transistors and resistors cost also very less. So that circuit becomes quite inexpensive. and it has the outstanding ability to amplify the direct current and low frequency signals. Okay, what is the main fetching of this one? It has outstanding ability to amplify the direct current and low frequency signal. It has the outstanding ability, okay, to amplify the direct current and low frequency signals. Okay, and see here, it has no coupling or bypass capacitor to cause a drop in gain at low frequencies. Okay, it has no coupling or bypass capacitor to cause a drop in gain at low frequencies. And while coming to the disadvantages, it cannot amplify high frequency signals, and it has poor temperature stability. So what is the main demerit? It's suitable for only low frequency signals. It is not applicable for high frequency signals. And see here, it has poor temperature stability. So poor temperature stability means here we are using transistors. The transistors are semiconductor devices, so the parameters are depends on the temperature. If the temperature is increased or decreased, it may affect the output. So like that, here it has poor temperature stability. That means the temperature is increased, that may affect the overall performance of the device. So if it will affect means it having poor stability, no stability. Even though the temperature is increased, the parameters are not changed means the circuit becomes stable. But here poor temperature stability means if the temperature is changed, the circuit parameters also changed according to the temperature. So that it termed as poor temperature stability. Okay, and cause of this, any variation in base current in one stage is amplified and the following stage, thereby of shifting the Q point. Means cause of temperature changes, if any variations are there, they must also be affected the Q point. And see here, while coming to the applications where we are using these RC in photoelectric current applications and thermocouple current applications. Okay, these are the applications of what? Direct coupled amplifier. So in today's class, what we have discussed? Transformer coupled amplifier and direct coupled amplifier. Advantages of transformer coupled amplifier, disadvantages of transformer coupled amplifier as well as direct coupled amplifier. So now see, once the key points in your examination, you are getting the terms like this. In direct coupled amplifier, the output is connected with the help of resistor, capacitor, transformer. Nothing is there, means simply no element. So what is your answer? No element. Okay, in the direct coupled amplifier, the output is connected from one stage to another stage. A resistor, B capacitor, C inductor, D no element. So what is our answer in direct coupled? No. And while coming to the resistor coupled amplifier, also like that. In RC coupled amplifier, the output of one stage is connected to the input of next stage through the resistor, capacitor, inductor, no element. What is our answer? Capacitor. And in amplifiers, the capacitor is called blocking capacitor. A, it blocks AC. B, it blocks DC. C, it blocks both AC and DC. D, all of the above. So what is our answer? It blocks DC only. It allows only AC. That's why it is called blocking capacitor. And next, in amplifiers, the R1, R2 provides biasing and stabilization, or low reactance path to the amplifier signal, high reactance path to the signal, and high resistive path. What it meant? Biasing and stabilization. And while coming to the next one, direct coupled amplifier is suitable for low frequency signals or high frequency signals or moderate frequency signals or very high frequency. What is our answer? It is used for low frequency signals. Okay, and while coming to the next important question in your examination, our question paper either mid 1, mid 2, external exam having 1 mark, 3 mark, 5 mark question. So in 5 marks question, the questions are like this: explain the construction and working of two-stage transformer coupled amplifier with its frequency response. So here circuit carries 1.5 mark, theory carries 1 mark, and also your frequency response carries 1.5 mark. So here the frequency response of each and every amplifier is very important. RC amplifier will provide a constant gain. transformer will provide the variations, means poor response, and direct coupled amplifier will provide the good frequency response for low frequency signals, but bad frequency response for high frequency. Means at high frequencies the gain must be reduced. The reduction is called falling. Okay, so this is about what our RC coupled amplifier as well as transformer coupled amplifier, direct coupled. Among all these, which one is suitable for high frequency? Transformer coupled. Which one is suitable for low frequency? Direct coupled. Which one is suitable for our moderate frequency? That is called two-stage RC coupled amplifier. Okay, so this is about today's class. Now I would like to conclude. Meet you in tomorrow's class.